So we are on lesson 27 and we're still continuing our discussion on electric circuits. In this lesson, we're going to talk about resistors that are connected in parallel. So please watch that lesson before you watch this one. It's very important that you do that. So let me just to start off this thing. Let me just draw a circuit diagram showing resistors that are connected in parallel. Okay, so we have this simplistic circuit diagram over here. We have a battery. Let's say it supplies an external voltage of 12 volts, and then we will have a current, conventional current flowing from the positive terminal of the battery to the negative terminal. So we have IT over here. And let's say IT was, I don't know, 2 amperes. So what would happen is that we would have that the current would go flow there, and then when it reaches here, you'd see that at this point it will actually split. So it would split into this branch I1, and then also we have another current here, we just call it I2. So it's not the same thing as with resistors that are in parallel, because now you see these resistors are on separate branches. If they were in series, they would be on the same branch. So there's actually splitting, this a dividing of the current that occurs when current flows through this branch, and it has to also flow through another branch there. So what we would find in terms of the current, we find that the total current will actually be made up of I1, the current that flows through this branch through the resistor R1, plus the current that flows through this branch through the resistor I2, right? So if, let's say, for if these two resistors were equal, then a current of 1 ampere would flow through this branch, and another current of 1 ampere would also flow through this branch over here. Remember, like I said, there's no current flowing through your voltmeter because it has like an infinite resistance, so there's no current, or at least ideally there's no current flowing through it. So now let us talk about, so like I mentioned, this is, they call them current dividers. So resistors that are connected in parallel are current dividers. So it's always about just following the current. Is it splitting? Is it not splitting? Okay. So now let us move our discussion to the potential difference. So what we would find if we measure the potential, if we supplied an external voltage of 12 volts, and then we put a voltmeter here, we would find that we would actually measure the same 12 V. Even if this voltmeter over here will also measure a voltage of 12 volts. So what is that telling us is that the potential difference V is actually the same. So meaning V external will be equals to the potential difference at this resistor 1, as well as the potential difference at this resistor 2 there, which is in this case 12 volts, provided what is it that you're given as your external voltage. So remember, this voltmeter here measures the potential between these 2 points for the whole circuit, and this one measures the potential difference between these 2 points, and this one measures the potential difference between those 2 points. And also, if we're looking to find what is it, the resistance. So if we continue to add resistors in parallel, the total resistance will actually decrease, because it's actually given by this relation. So we would have 1 over rp because they are connected in parallel, which is over 1 over r1 plus 1 over okay, that is not in the short. So 1 over R1 plus 1 over R2, depending on the number of resistors that you have. So you'd find that if we add more resistors to your circuit, the value of RP would actually keep decreasing. Remember, it's different from resistors that are in series. In series, if we keep adding resistors, the total resistance of the circuit will actually just keep on increasing. But with this one, if we add resistors, it decreases. So those are just some of the important things for you to note. So without wasting any time, let us now do a simple calculation to kind of reinforce everything that we have studied so far, or that we've talked about so far. Okay, so now let us say that we have a circuit diagram like this one, where the battery actually supplies this positive terminal, negative terminal. So meaning that conventional current will flow in this direction. Let's call that IT, the total current supplied by this battery. All right. So the battery actually supplies a potential difference of 12 volts that is given to us. Then we have current through our ammeter. Remember, the ammeter has zero resistance, so all that current actually just flows through this ammeter A, right? And then here at this point, the current would actually split it from to this branch as well as this branch. So in this branch we'll have current I1 because of this resistor there, and current I2 because of this resistor over there. And the value of that of our resistor R1 is 2 ohms. There to it is connected a voltmeter V1. The value of R2 is 4 ohms. Connected to it is voltmeter V2. There's no current flowing through the voltmeters, so that current will go there up until we find ourselves there, the direction of the current. So it's from the positive to the negative terminal. Okay, so let us now look at the questions. The questions requires us to calculate the reading on ammeter A1 as well as A2, as well as the reading on voltmeter V1 and V2. So let us try to do that. So how do we go about solving this problem? So we know that the reading through ammeter A, like I said, is the total current. Remember, this is connected in series to the battery. It's the total current that is flowing through here. It only splits at this point, right? So to find the total current using Ohm's law, we know that the current is directly proportional to the potential difference, VT. I said we can actually use VT is just actually that external voltage provided by the battery, which is also equals to RT. Do we know what so we know we have this. Do we know what this is? No, we don't know what it is, but we can definitely calculate it using our equation. 1 over RP equals to 1 over R1 plus 1 over R2, right? So 1 over is 1 over 2 plus 1 over 4. This gives us 1 over RP equals to, how much is that? This is going to be 3 over 4. And then it's just a matter of, if you want to make RP the subject, it's just a matter of inverting this whole entire thing. And then RP is actually just equals to 4 over 3 or 1,33 ohms, right? So that is the value that you're supposed to come to. Let me see that it's not clear. It's 1,33 ohms, right? Okay. So now that we have this value, we can go back to our equation and actually determine what IT is. Remember, it's the total current flowing through that ammeter A. So IT V external, the total external voltage provided by this battery is 12, and then this whole thing is divided by 1,33. And I think you're supposed to come to a value of approximately 9 amperes, right? So that is the total current that is flowing through your circuit. Okay, but now to calculate A1 as well as A2, because now this this ammeter will actually measure the current that actually flows through this resistor. This ammeter will measure the current that flows through this resistor. So to find A1, we know that it splits, right? It's going to split. The total current is going to split because they are connected in parallel. So to do that, I'm just going to wipe this thing. We have to look in terms of what is it that we have and what is it that we know. So we're looking for A1. So meaning we have to use I1 still from what is it? Ohm's law. I1 is equals to V1 over R1. So this is just Ohm's law, right? Do we know what I1 is? No, that's what we're looking for. Do we know what V1 is? Well, we can find it. R1, we definitely know the value of R1. So how do we find V1? We find V1 by remembering that resistors that are connected in parallel have the same potential difference as the total supplied there, right? So we will know that V external equals to V1, which is equals to V2, and that entire thing is it's 12 volts. So that's an important thing. The total external voltage supplied by this battery will also be the same voltage that this voltmeter reads on this resistor, as well as the same voltage that this voltmeter reads on this second resistor. So that's something important for you to know. Okay, cool. So if we have that, we can see that we actually now know what V1 is, the same as external voltage, which is 12 volts. So we can calculate I1 and say it's 12 volts divided by the value of what is it? The value of V of R1 is 2. So that's just 12 divided by 2, which is going to give us 6. And then to find I2, it's the same thing. We say 12. So it's V2. Let me do it properly. So it's V2 divided by R2, right? So the value for V2 it's 12 volts, and then the value for R2 is 4 ohms. So 12 divided by 4 is actually 3 amperes. So what are you seeing? If we add IT, we said resistors that are in parallel are current dividers, meaning that the total current will be made up by I1 plus I2. And then we found that I1 to be 6 plus 3, which will then give us a value of 9 amperes. This is the same value, this is the same number we found when we calculated the total current in the first question. All right, so what is the next step? The next step is actually quite straightforward. It doesn't require a calculation. Now it's asking us what is the reading on voltmeter V1 as well as voltmeter V2, and our answer is that because this if two things are connected in parallel to each other, they will actually this voltmeter will read the same value as the one supplied by the battery as well as this one. So meaning that so we say V1 equals to V2, which is equals to V external, which was equals to 12 volts, because these are connected in parallel. Okay, I hope that is clear. But also there's also another way that we can use, as we have done in the previous lesson, where we actually use the ratio. So I'm going to show you how to do that quickly. Okay, so to use our ratios, we would say, okay, the ratio of R1 to R2 is nothing but 2 is to 4, which is, if we simplify it, divide both sides by 2, which is our common denominator, our common factor, we then say it's 1 is to, what is it? 1 is to 2, right? But remember that according to Ohm's law, resistance is inversely proportional to current. So if you want to find the ratio of I1 to, or the current through the resistor R1 and the current through resistor I2, it's just a matter of swapping them because they're inversely proportional, which means it will be 2 is to 1. So you see here in terms of the resistors, it's 1 is to 2, but for current, it's 2 is to 1. So now we know what the total current is. We found it in the previous equation they give it. We found it to be 9 amperes. So to find I1 again, I would say I1 is equals to the total current, which is 9 amperes, multiply by 2 parts of I1, so 2, and then divided by the total parts. So it's 9 multiplied by 2 divided by 3, so that's 18 divided by 3, which will give us 6 amperes. The same thing for I2, it's the total, which is 9. Okay, I don't want to write this ampere here, which is 9, and then multiplied by the one part of I2 divided by 3, which is the total plus 2 plus 1. And then so that is 9 divided by 3, which is 3 amperes. So see, we still get to the same answer as we did previously. I hope everything was clear. If it wasn't, you're more than welcome to always drop me a message on WhatsApp, and also we'll discuss this even further when we meet for our live session.